Everybody to tonight's webinar, once again brought to you by iGenis Healthcare Nutrition. Now, tonight hopefully promises to be quite exciting. It was certainly very exciting for me doing all of the reading and research, which I've been puzzling over for the last 4 or 5 days, trying to get my head around all of the immunology behind inflammation and autoimmunity. So tonight I'm really going to focus on kind of the biological basis of autoimmunity, how inflammation both factors into the progression and onset of autoimmune disease. I'm going to look at some of the triggers and a few of the sort of clinical approaches to managing autoimmunity, but I'm going to focus specifically on the nutritional resolution of inflammation, and then hopefully down the line I'll do another autoimmunity webinar where I look at a little bit more about the other systems and structures and processes involved in autoimmunity, because as with so many things scientific, when you start reading, you end up asking yourself more questions than you're possibly able to answer. So there are so many other things I could have spoken about but didn't get the opportunity to. So tonight I'm focusing on inflammation and autoimmunity and how we can look to restore inflammatory regulation via a nutritional approach. So what is autoimmunity? Well, autoimmunity arises when the body seems to no longer be able to recognize proteins and cellular structures and integral aspects of the human biology as self. And what happens is the body begins to attack itself. The immune system mounts a response to its own cells, its own integral proteins, and starts to slowly, progressively break down and destroy whole organs and eventually whole body systems. And we see it obviously commonly in the gastrointestinal tract with things like Crohn's and celiac, and we also see it quite commonly in the central nervous system, multiple sclerosis, for example. But it can happen all over the body and it can happen to any organ. Now, the specific target tissue that our body decides to mount its immune response to and attack and slowly break down until it's unable to function depends on our genetic susceptibility. We have a number of single nucleotide polymorphisms in our genes, which are individual base pair changes. And please stop me and I'll clarify anything that doesn't make sense if I'm going too biochem or genetic or sciencey on you. Any questions, do sort of filter them in if they're relevant at the time, otherwise I'll take them at the end. So we have these genetic changes. They're very minor changes that wouldn't normally impact our day-to-day genetic capacity, but we do see that this can alter our susceptibility to the type of autoimmune disease that can happen. Then, of course, we've got diet factoring in there. That's going to have a huge impact on whether or not we actually become autoimmune affected. And then we have lifestyle as well as environmental triggers that are all going to contribute there as well. As things stand, there seem to be over 80 known and classified autoimmune diseases, and as such it's become recognized as the third biggest cause of morbidity and mortality in civilization of the Western world. So that's pretty huge. That's a lot of people being affected in first world countries, so it's pretty scary. But if you think about the pathogenesis and mechanisms behind cardiovascular disease, that is a huge inflammatory based condition. So lots of clinicians are now starting to say, do you know what, actually cardiovascular disease is an autoimmune condition. So all of a sudden autoimmunity becomes the first biggest cause of morbidity and mortality in the Western world. So here's just some of the conditions that you've hopefully, possibly, probably, but ideally not seen in clinic, or you know someone with, or you suffer from one or maybe several yourself, or have done in the past. And a lot of those, you can see very clearly that they're affecting all different systems of the body. You've got digestive tract, you've got the heart, you've got diabetes, the pancreas, you've got the thyroid, you've got the central nervous system, skin, everything in there that can be attacked by the immune system is being attacked by the immune system in different people, resulting in a whole host of different conditions. So the biological basis of autoimmunity, as I've sort of touched on already, involves three key factors. Firstly, we need a trigger. We need something that's going to switch on our immune response. And this can be a viral infection, it can be bacteria or yeast, it can be food sensitivities, and it can be stress. And basically, as a result of one of these triggers, the immune system is then either chronically activated, or the trigger itself expresses proteins similar to proteins that are integral to our own cells. And what happens is the immune system then starts to lose its ability to just recognize those external problematic invading microbes and protein structures, and actually starts to then latch on to our own cells. So both in the case of viruses and a number of food sensitivities, these invading pathogens contain a number of protein structures very similar to the proteins that we express within our own cells. Indeed, viruses are actually integral to our own DNA. We've lived with viruses for so many years that the viral DNA has now become one with ours. And so you can see that if we have a chronic viral infection, and for many, many, many virus types, once you've got a virus, it stays with you forever, even if it's not active. That constant representation of virus within cells is going to then trigger your immune system to be looking out for protein structures that may be expressed within our own cells. Lectins, for example, we actually have our own lectins within the body that we produce. So when we consume foods that contain lectins, such as wheat germ agglutinin, we're going to start to be latching onto our own lectin protein structures and breaking those down and targeting them. So that becomes a little bit concerning, but also both in the case of bacteria and yeast, as well as stress. Sorry, yes, Carol Ann Barrett, you've figured out how to put your hand up. Fantastic. I'm assuming you meant to do that. If you did, there's the chat box to ask a question there, so please feel free to type away. Otherwise, I'll carry on. So both bacteria and yeast infections, as well as stress, are going to cause this sort of chronic activation of the immune response. And that in itself, the more the immune system is switched on, the more those bacteria and yeast proteins are present. Yes, Janine, and parasites, that's sort of it's something I haven't specifically expressed, but it's in there. The viral infection, it should be viral, and parasites, it's just infectious agents, really. That's something I'll discuss sort of a little bit later. So bacteria and yeast, as well as stress, chronic activation of the immune response, basically meaning that the immune system gets itself a bit confused and overwhelmed, and the regulation of the immune response gets lost. So we add to the fact we've got our trigger in place, we add to that the environmental aspect. So diet's obviously huge. The impact of our diet on our ability to regulate immune and inflammatory systems is vitally important, and I'm sure you're all well aware of the role of zinc, vitamin A, vitamin E, vitamin C, selenium, vitamin D in immune regulation. But then, of course, you've got the fatty acids in inflammatory regulation, which is obviously what I'll focus on tonight. So that's a massive aspect of being able to actually resolve and control any immune response and deal with one of these triggers effectively. But our diet can also affect our gut bacteria. As many of you are hopefully well aware, the type and number of the right bacteria in our digestive system plays a massive role in our immune capacity and our ability to quickly deal with invading pathogens. If our gut system is functioning with the right bacteria, then a lot of these triggers may never actually make it into the blood in the first place. If we have a poor diet, we tend to have poor stomach acid as well as low enzyme capacity in the stomach, but we can also start to treat things like insulin insensitivity as well as leaky gut. So again, going back to food sensitivities, this can cause permeability of the gut barrier, which can further lower our defenses against all of these triggers. Then, as mentioned, as a result of these single nucleotide genetic polymorphisms, the trigger gets in, the environment allows the trigger to proliferate and switch on the immune system, and the genetics then determine which one of our systems are going to be most likely to be susceptible to that damage. So the next 4 slides I'm just going to touch on very briefly. You will all be sent the slides after this presentation, and they'll be available on our website as well, so you can look through these in more detail. So we've got 4 key sort of mechanisms by which these triggers can stimulate an autoimmune disorder. So molecular mimicry is possibly one of the main ones, and that's sort of the one that I mentioned through viruses and things like lectins. Basically, these agents get into the blood and they carry protein structures that are similar to protein structures that we have in our cells. The immune cells then recognize these, switch on an immune response. But if that infective agent is continually there, continually switching on this immune response, then we will get activation of the immune response towards our own proteins. Then we have protein changes and cryptic agents, and basically this is where things like stress are causing chronic damage to our cells, and the body then starts to recognize and target the proteins expressed by our cells that have been damaged as being problematic themselves. So whilst initially it's the damage that needs resolving, if that damage is ongoing, the immune response will directly target the cells and the proteins expressed by those cells that have been damaged, and that can trigger autoimmunity. Superantigens, this is to do with viruses in many respects and microorganisms. Sarah, you asked which parasites. It's not my area of speciality, but things like H. pylori, for example, is a big sort of stomach parasite that people suffer from considerably. So things like that, sort of integral things that get into the blood and the digestive tract that can stimulate ongoing immune response. So these infectious agents carry really strong immune triggering capacity, and basically the stronger the immune triggering, the more likely it is to get upset. So the more we're stimulating it, the more it's likely to go wrong, and then you can again start to lose control slightly of the peripheral immune cells, and they start bouncing around and going off and attacking things that they shouldn't be. And then finally, you've got your bystander activation. So this is sort of secondary autoimmune to autoimmune, which is as scary as it sounds, but as I'm sure a lot of you are aware, you might have somebody presenting with an autoimmune condition, and then they've also got another one, for example, celiac and type 2 diabetes. Type 1 diabetes tend to be very commonly co-expressed. Lots of people with an integral or quite severe autoimmune disease will also have things like psoriasis. Cardiovascular diseases is quite often secondary to things like arthritis. So what happens in this case is that you get your original autoimmune trigger coming in, causing that autoimmune condition, and then you have other things just kind of lingering around that are involved or not involved in the immune process, and cells of the body that express similar structures to the original cell that's being targeted, and then they start getting drawn into the equation as well. So whilst you were perhaps originally destroying your synovial joint area, you might then be ending up destroying the skin cells and things like that. So that's your bystander activation. So when it comes to the role of inflammation within the body, it is essential. It's necessary. We need inflammation because it's the way our body deals with all pathogens and all damage that occurs within the body. So regardless of whether it's an infection, a parasite, stress, we will mount an inflammatory response. And this is an innate and non-specific immune response. So we all have the capacity to create an immune response right from birth. We don't need to learn it, but as a result, it's not specific to any given type of invading pathogen. What then happens is the pathogen that is entering into the system is recognized by different structures within their cell membranes, known as PAMPs and DAMPs. So they're either pathogen-associated molecular proteins or damage-associated molecular proteins. And these specific protein structures are then further recognized by our immune cells, specifically the macrophages and the dendrites. And what happens is the macrophages and the dendrites recognize these molecular protein structures expressed on the surfaces of the pathogen and damaged cell structures. They latch onto them, they engulf them and surround them, and then that subsequently triggers to those macrophages and dendrites to start pumping out inflammatory cytokines. And this is the very first stage in the inflammatory cascade. However, if this antigen presence, whether it be because of chronic stress, because of an infection, or because of an ongoing ingestion of food that we're insensitive to, if that antigen presence within the body persists, then the body actually starts to process it much further than just mounting an immune response, and it starts to create a learned adaptive immune capacity to deal with these problems. So the macrophages, monocytes, and B cells specifically take up and process those antigen containing pathogens and present them to what are known as naive T cells. So this is a subtype of immune cells that go on to trigger the generation of antibodies. Now, according to the specific trigger that's entered the body, according to the specific PAMP or DAMP expressed, these T cells then differentiate into a number of different subtypes of their own, and each of those subtypes will then pump out its own inflammatory cytokines, which both triggers the replication and growth of that specific subtype of T cell, but also the replication and growth of the B cell that's going to deal with that specific trigger. So this is a very nice diagram just showing sort of clearly what I just said, hopefully. So APC stands for antigen presenting cells. So that's our monocytes, macrophages there. And you can see just there, there's an antigen represented by AG, just being sort of nicely presented on what looks like a red candle towards the native CD4 T cells. And then depending on what that T cell has recognized as being the type of invading pathogen, we then get a number of different T subcells being produced. That occurs in the presence of different cytokines, and each of those subcells of T subtype then express further cytokines that are specifically relating to the pathogen that they need to deal with. So just looking through that list very quickly, you can see Th1 is involved in cell-mediated immunity by dealing with bacteria and viruses. Th2 is important for dealing with parasites. Th17 is related massively to cell-mediated inflammation, and this is the one that seems to be most commonly recognized to be a key driver of autoimmunity. And then you've got the Treg cells, which are actually immunoregulated, and they actually help with the resolve and switching off of the inflammatory process. So once this antigen has been produced, the antigen-specific antibody has been produced, so the B cells, the T cells will trigger the B cells to make antibodies, which are specific proteins. We all know of IgE, IgA, IgG, IgM. They're antibodies, and they will actually come along, latch on to those original trigger proteins and help the body to recognize and break those down. Once we've developed this capacity to actually make antibodies to a specific pathogen, this is remembered for the rest of our lives. So this is part of our adaptive immunity. And it's at this point, once the body has generated these antibodies towards the initial trigger, but those antibodies are starting to recognize similar protein structures or just structures within our cells that are present due to the ongoing inflammatory process, the immune system has now learned to directly attack and destroy our own cells, organs, and systems. And the problem with that is that any point where you're then exposed to that initial trigger, that can mount the same immune response that originally triggered the autoimmunity. So you can see that once you develop that autoimmune condition, whenever you're exposed to what originally triggered your body to recognize itself as an antigen, is going to cause problems. So I'm just going to have a quick slurp of my drink. Any questions up to here? No, wonderful. I will press on. So with that in mind, there's two kind of major approaches in order to actually resolve inflammation and autoimmune conditions. The first of which, we need to obviously reduce our exposure to those initial triggers and ideally totally eliminate them from the equation so that they're not continually triggering the immune activation. Then we also need to be thinking about directly reducing inflammation and the specific cytokines involved in driving and progressing the inflammatory and autoimmune reaction. So in order to reduce our exposure to initial triggers, we obviously need to understand what it is that's potentially causing an infection. Is it a parasite in the digestive tract? Is it a bacterial infection, a yeast infection, or a viral infection? And we can do this via testing. Many of the labs or even medical professions will offer stool testing, blood testing, and general pathogen screening panels if that's something you want to go down. If it is recognized as a digestive tract parasite or bacterial infection, then you can use digestive enzymes to help you break down those parasites that are present. But then obviously there's the nutritional approach via using antimicrobials via olive leaf, oregano oil, garlic, lemon juice, and lots of other things out there that can be used. But obviously it's if you're unsure of what it is that is causing the original infection, it's often useful to do some sort of testing. Great if you can request it and get it done through the GP, but then obviously research the specific approach and switch between antimicrobials if things aren't working, double them up. You guys know what you're doing, so I don't need to go into that too much. We then obviously need to restore the gut dysbiosis so that we reinstate that first line defense against the infection in the first place. Probiotics, very, very important. And we need to be looking at the diet, making sure that people aren't eating high volumes of refined carbohydrate. Obviously, fiber is very, very important for us, but think about the sources of fiber and make sure we're not putting in things that are going to upset the gut and also reduce our capacity to actually deal with infection. So natural organic diet based on vegetables containing high natural antioxidant phytonutrients, low in toxicity and low in inflammation, and potentially food sensitivity stimulating grain-fed meats. So leaky gut's obviously a huge factor, and it's one of the things I would love to have been able to talk about a bit more today if I had more time, but maybe next time I'll get to talk a little bit about gut permeability. This seems to be a massive, massive factor in the onset of autoimmunity, and most of the experts out there today are sort of preaching that you will be hard pressed to find anybody with autoimmunity who doesn't have GI permeability. So you need to be looking at food sensitivities. What has triggered that gut permeability in the first place, eliminating those foods from the diet either via rotation or total elimination, and also getting your gut healing formulas in there, so things like glutamine, aloe vera, DGL licorice, and all of the wonderful things that you can do to repair and rebuild the gut lining and tighten those tight junctions again, prevent things from getting through the cells that aren't meant to and into the blood and causing the immune reactions that we see. Stress, as I've already touched upon, is vitally, vitally important. Stress can actually directly cause leaky gut. It's one of the major factors that's implicated in leaky gut, along with things like antibiotic use, chronic prescription medication use, high alcohol consumption. So all of these things, when you look at the causes of gut permeability, you start to realize that very few people in the UK certainly have not got leaky gut, because we've all at some point been subject to those practices that result in leaky gut. But stress particularly, very, very, very important. Stress does directly suppress the immune system and just dysregulates everything involved in regulating the immune system and allowing us to directly attack infections as well as keep our hormones under control. So we need to be, and I'm sure, again, hopefully most of you are doing this already, helping clients and ourselves to be re-evaluating our priorities and our values, to understand why is stress a factor? How has it allowed us to get to that point where it's become a trigger? Are people, so obsessed with building themselves a future that they're not thinking about how happy and healthy they are now? Are they running around after 53 dogs and 17 children and a partner who does nothing towards the house and the family? How can we help them to understand that actually investing some time and effort in themselves now and thinking about how happy they are now is going to massively impact their health? Mindfulness is obviously a huge practice associated with stress reduction, really, really helpful and important in just resetting that balance, getting people back to the now, stop dwelling on the past, stop obsessing about the future, and realize that now is all we really have. Active self-care, again, really important. Just there are a lot of people out there, and I'm sure you've all seen it certainly. Chronic fatigue is an area where people just don't seem to realize that sometimes it's okay to take time out to look after yourself and just play it down for a while, to chill out. And this is really important again in autoimmune disease, just to make people aware that looking after themselves is sort of the first port of call in the road to recovery, really. And then, of course, having that support network around them is really, really, really necessary, not only to help them manage their autoimmune condition, but also the stress associated with the onset of that condition in the first place. So that's that very, very briefly. And as I said, I'd love to go into a lot of those things in a lot more detail, but I'm here to talk to you today more about inflammation and cytokines. So the real kind of key in the biological manifestation of autoimmunity and how we resolve it and prevent it in the first place is to reduce the inflammatory load and subsequently reduce the cytokine production. So this is just to kind of go over what I went through with that slide earlier, and just to say that pro-inflammatory cytokines determine the type of T cell that are then made. So again, whichever trigger comes into the body and is recognized and presented to these naive T cells goes on to determine the cytokines that are pumped out into the system, and that determines which T cell is then made as a result from the naive T cells to allow the specific type of invading pathogen to be recognized. As I mentioned earlier, looking at that diagram, Th17 seems to be the major contributor when it comes to autoimmunity. And this has actually been fairly recently recognized. Previously, the T cell understanding was revolved largely around the Th1, Th2 balance, and you've probably heard us talking about it in the past, and you've probably read about it a lot, but Th17 is sort of the new kid on the block, and it's one that's heavily implicated in autoimmunity. Then we've got our Treg cells there, which suppress the activator cell activity, so the other T subtypes are T activator cells, and it dampens the immune response and helps us to actually resolve inflammation, resolve immune activation, and prevent autoimmunity. And as I mentioned, each of those individual T cells actually secrete their own cytokines, and cytokines are the chemical signals that go out into the blood, they go out into the lymphatic system, and they say, hey, lymphocytes, hey, leukocytes, hey, phagocytes, come here, we need you, we need your help, we've got this virus over here attacking us, and we need you to come and help us deal with it. So they're to quote Tom O'Brien, they are the armed forces that come and help us deal with those attacks. So, as I mentioned, it's the Th17 cells specifically that are being increasingly understood to play a major role in both the regulation of the inflammatory process and then further contribution to autoimmune disease. And a number of studies have directly shown that high amounts of Th17 cells and as a result interleukin 17 expression is involved in the onset and progression pathogenesis of rheumatoid arthritis, lupus, and lung skin autoimmune disorders. But also, we need to kind of just take stock for a second when it comes to the inflammatory and immune response, because whilst it's very easy to demonize inflammation and very easy to demonize certain cell types within autoimmunity, there's a reason all of these cells exist. And similarly with Th17, it's produced by the body for a reason, to fight infection, and it's necessary. So whilst reducing Th17 does directly reduce inflammation and autoimmune disease, it's also very important in our initial immune response anyway. We just don't want to let it get out of control. And studies have actually found that Th17, not just in autoimmunity, but in cancer as well, is a bit of a double-edged sword, because it can both prevent and promote the growth of cancer. So this is just another paper showing the importance and contribution of Th17 cells. So you've got a number of different autoimmune diseases there. Then you've got the fact that Th17 predominantly just produces interleukin 17 and interleukin 22 within the blood and the body, and then it details there the type of interaction within the body and the stimulating immune effect that these cytokines have in the various different related disorders. And again, I don't want to go into that too much because you can have a look at these slides in more depth. That paper at the bottom there is one of the major papers I've used to write this talk. It will be included in the references at the end, so please go off, read it in depth, and have a look at the individual references that they quote there relating to Th17 in those specific conditions. So we know that Th17 and autoimmunity are very, very closely linked, but Th17 is also very important in a balance. As I mentioned, whilst it's easy to demonize the likes of Th17, it's important, but the balance is very important with other T subtypes. Th1 and Treg cells relative to Th17 are an important indicator of our risk and severity and likelihood of developing an autoimmune disorder. So things like sclerosis, osteoporosis, irritable bowel syndrome, irritable bowel disease, not syndrome, have been directly shown to correlate with low Th1 relative to Th17 cells. And similarly, low Treg, which is sort of unsurprising given that Treg cells regulate the pro-immune response of the other T subtypes. That's a very important balance as well in determining the onset and progression of autoimmune diseases. And I think specifically arthritis and skin-related disorders have been linked there. So it sort of goes without saying then that if high Th17 results in autoimmunity and the balance between the Tregs and the Th17s can predict onset and progression of autoimmunity, that both high inflammation and high cytokines is going to directly inhibit Treg cells. But in addition to the ability of Th17 and the high inflammation that it causes inhibiting Treg cells, we also see that scarily Treg cells have the ability to turn into Th17 cells. So this is IL-17 and IL-22 expressing cells in the presence of a high inflammatory load. So as with many things inflammatory, the more inflamed we become, the more inflammation is stimulated, which signals a direct inability for the body to cope with this inflammatory load. So we need to be thinking about how we can readdress this inflammatory load, because in the presence of high inflammation and high cytokines, Tregs turn into Th17 cells and further shift that balance towards inflammation and away from the ability of the Tregs to regulate the immune response. Okay, so I'm now going to go into a little bit more depth on the inflammatory process, and this is where we get into the nutrition. Hopefully you'll be pleased to know. So there is usually a very tightly regulated inflammatory response within the body. What happens as a result of our immune or inflammatory trigger? The body produces leukotrienes, thromboxans, prostaglandins, and these are derived from essential fatty acids. Now, there is a point at which inflammation reaches maximum capacity, and the threat that caused the original inflammatory trigger, whatever that was, should have by this point been relatively dealt with. At this point, the type of eicosanoid, which is the leukotrienes, thromboxans, prostaglandins, is switched, and they start to become anti-inflammatory rather than pro-inflammatory. And this balance slowly levels out until anti-inflammatory production of eicosanoids rises to a point where it says to the body, enough's enough, time to switch off inflammation completely. So the inflammatory process terminates and we see resolution. Now, similarly to autoimmune disease, we know that diet, chronic stress, and general sort of environmental factors can trigger the onset of the inflammatory response and can trigger it chronically. So if we've constantly got any of these factors that can trigger inflammation present, the inflammatory process is going to be going and going and going and going and going. Failure to switch off our inflammatory process means that we're at very high risk of chronic inflammatory based conditions. This leads to both the activation of our stress response axis, the HPA axis, as well as upsetting our immune system. As you now know, the more inflammatory cytokines we pump out, the more likely we are to develop a full-blown response where we're creating antibodies. But inflammation also interacts with our hormones, and affects our psychology as well. So there's a lot of things that can start going wrong when we see high amounts of inflammation. So as I mentioned, the precursor to these pro and anti-inflammatory eicosanoids are actually our omega fats, both the omega-6s and the omega-3s. So it becomes quite apparent when we think about the roles of high inflammation and how that can dysregulate so many different biological systems, that the omega-3 to 6 ratio is very, very important. And whilst historically we're all very well aware that the human diet was nice and even at around 1 to 2 to 1 omega-6 for every omega-3, over the last few decades particularly, the changes in this balance have been just phenomenal. We are now eating, many of us, in excess of 20 to 1 arachidonic acid or omega-6 molecules for every omega-3 molecule that are intaken. And this is largely because of our processing and refining and all of these weird and wonderful modern foods that just should not be appearing on our plates. Now, why is this a problem? Well, it becomes an issue when any one of the omega families dominates in the diet, because the ability of our body to process, convert, and metabolize these fats into the useful subtypes of the omega-3s and the omega-6s actually shares the same biological mechanisms and reactions. So if you've got tons of omega-6 and very little omega-3 coming into the diet, the body's just going to be processing and using omega-6s and neglecting the omega-3s. And the omega-3s are going to be sort of the runt of the litter in the corner there, going, oh, I want some milk, I want some milk. But obviously not getting any from mummy pig or whatever it is, because they're so small and incapable of latching on to these enzymes because they're just not forceful enough and not enough of them. So the body's not able to process the omega-3s and produce the healthful functional omega-3s that we need to balance out this ratio. Whilst the omega-3 to 6 ratio is very, very useful to us in understanding the diet and understanding the type of health load within the body, we now know that each of the omega-6 and the omega-3 fats are very individual. They have different roles within the body. So when it comes specifically to the inflammatory process and understanding the importance of inflammation in autoimmunity, we realize that just looking at the omega-3 to 6 ratio is not reflective enough of inflammatory health status. So we need to be thinking about more key and more specific biomarkers to understand what could be going on at a biological and biochemical level. The omega-3 index can be really helpful in understanding our level of EPA and DHA, which are the two major omega-3 fats associated with all of the health benefits, but specifically the arachidonic acid to EPA ratio is really, really important when it comes to inflammatory resolution. And that's just kind of really to highlight what I just said. When we're thinking originally about the omega-3 to 6 ratio, we're looking at all of these fats grouped together and more. I mean, this is a simplified diagram. There's several other in each family of fats. But we know that each of the fats does different things. It plays different roles. We know that the parent fats are important for structure. We know that the ability to convert parent fats into the longer chain fats is not very efficient in many of us. And we know that whilst both EPA and DHA are very, very important omega-3s, EPA specifically is the one that does a lot of the physiological things associated with omega-3 benefits. DHA vitally important for structure. And arachidonic acid is very much sort of out there on its own in terms of being really only omega-6 that we need to be thinking about as a concern, particularly in the inflammatory process. So whilst everybody worries and stresses about having high omega-6 levels, the only reason that is a problem is if our omega-3 and specifically EPA levels are low, because then the body's capacity to make arachidonic acid is considerably higher, meaning our inflammatory capacity is considerably higher, and we end up suffering from inflammatory based disorders. And this is why AA and EPA have such a tight and very, very important relationship when it comes to inflammation and immune health. Basically, you can see the columns there. You've got arachidonic acid. It creates inflammatory eicosanoids in the form of series 2 prostaglandins and thromboxanes, and series 4 leukotrienes, as well as hydroxy fatty acids. Now, EPA has the ability to produce the same eicosanoid families, but different series. And these series of eicosanoids derived from EPA are considerably less inflammatory and considered anti-inflammatory relative to arachidonic acid. And whilst the other omega-6, the longer chain omega-6, DGLA and GLA, and to some extent DHA, are involved in the inflammatory process, because of arachidonic acid's huge pro-inflammatory drive, we need to be specifically looking at EPA levels to balance out the inflammatory process. So that just really highlights what I've just said. Your main pro-inflammatory lipid is arachidonic acid. Now, as I said, arachidonic acid is produced in the body in very high amounts when our omega-6 levels relative to omega-3, specifically EPA, are very, very high. So if we're eating lots of vegetable oils, we're eating lots of grains and refined grain products, as well as grain-fed meat, so we're going to be consuming and producing massive amounts of arachidonic acid. When we're not eating good quality flaxseed oil, good quality fish, oily fish, if we're cooking it at high temperatures, if it's not wild, then our omega-3 relative to our omega-6 is scarily low. And as I said, most studies looking at AA to EPA ratio and omega-3 to 6 ratio are now finding that people in the UK and the US are eating nowhere near enough omega-3, and that their AA to EPA ratio is often in excess of 15, even 20, in some cases 30 arachidonic acid molecules for every EPA molecule in our cell membranes. So this becomes really important in the immune system and in the inflammatory process, because the way our polyunsaturated fatty acids work and the way they contribute to immune function is through the incorporation into our cell membranes. So as I'm sure most of you are well aware, fatty acids in the form of polyunsaturated fatty acids are one of the main constituents of all of our cell membranes, including our immune cells. So these lovely fatty phospholipid structures that make up our cell membranes, that hold all of the proteins and the carbohydrate molecules and all of the ion channels and all of the things that make a cell work and communicate, are held together very tightly by the fatty acids that make up that lovely structure. The omega-3 and omega-6 fats are integral to those fatty acid structures and the phospholipid membrane. But in order for them to be involved in any of the body's processes with which we know that the fatty acids are involved with, they have to be released into circulation via the activity of phospholipase A2. This is an enzyme, and it essentially comes along, it sort of senses via various different chemical signals what's going on in the body, and it goes, right, I need some arachidonic acid. Snip, like a big pair of scissors. The arachidonic acid is then released into circulation, usually in the presence of an inflammatory signal. So again, we get our inflammatory trigger, high cytokine production. Phospholipase A2 comes along and goes, I need arachidonic acid. Snip, release that into the circulation. And then two further enzyme conversion steps occur to actually turn the arachidonic acid eicosanoid precursor into these immune factors, the prostaglandins, leukotrienes, and thromboxins. And those enzymes are cyclooxygenase 2. There is a cyclooxygenase 1 as well, but it's much more involved in gatekeeping activities within the body, things like looking after the integrity of our digestive tract lining, for example. So very important there. And then we've got lipoxygenase. So they are very, very important enzymes in the metabolism of arachidonic acid. So going back to that idea that EPA and arachidonic acid are very, very, very closely related and have very specific functions that sort of prevent and provoke one another. EPA, when high in cell membranes, actually has the ability to directly displace arachidonic acid from cell membranes. So the more EPA we eat, the more we consume, the more we're able to literally sort of buff arachidonic acid out of the way and say, be gone, you're not necessary. I'm taking up all of your space. So this automatically reduces the amount of arachidonic acid available to actually create those pro-inflammatory eicosanoids and signals in the first place. In addition to that, when we have good levels of EPA, we can actually switch off the cleaving, the scissor activity of phospholipase A2. So firstly, we've got less in the membrane, then we've got less released into circulation. So again, we're going to have less of that being actually turned into these pro-inflammatory eicosanoids. EPA has also been found to directly inhibit arachidonic acid metabolism. So even if it is in the circulation, it's floating around, EPA can actually stop it from being converted via cyclooxygenase and lipoxygenase enzymes into the eicosanoids, as well as being able to directly decrease the expression of the COX enzymes as well. So both of those have the direct ability to further reduce the pro-inflammatory load that arachidonic acid is capable of producing. So just to clarify, and hopefully it's clear already, but pro-inflammatory eicosanoids are derived from arachidonic acid, and they drive the immune and inflammatory processes. The anti-inflammatory eicosanoids derived from EPA actually act to directly oppose the ability of arachidonic acid to be turned into pro-inflammatory messengers and directly work to resolve the inflammatory process. So getting this balance between AA and EPA specifically is going to really help in preventing inflammatory load in the first place, as well as reducing inflammatory load in an already existing chronic inflammatory condition. And that's just looking at the AA to EPA ratio as a biomarker. Many of you may be sitting there thinking, well, how on earth do I know what my AA to EPA ratio is and whether or not I need to address it? Well, the good news is very, very soon we will be launching a fatty acid profiling test where you can, just from a pinprick of blood, figure out within a few days turnaround what your fatty acid profile is, what your AA to EPA ratio, what your omega-3 index is. And in addition to that, we will actually give you a personalized dose of omega-3 needed to raise your omega-3 index and AA to EPA ratio to optimal low inflammatory levels. So this is very exciting, and keep an eye out for news of the launch of that. Okay, so we know EPA is very important in resolution and prevention of inflammation. We know that arachidonic acid has the direct ability to drive and force this inflammatory process. And we know that the diet is so heavily in favor of arachidonic acid at the moment that even myself, working for IGenis and taking tons of EPA daily, I'm still probably slightly chronically inflamed. So there is a lot going on in there, but some people have autoimmunity, some don't. So what's the relevance of EPA in full-blown autoimmunity rather than just the inflammatory process? So we know that EPA can directly compete for the activity of COX and LOX with arachidonic acid, which reduces the inflammatory load in the first place. In addition to switching off the inflammatory eicosanoid production and therefore reducing the cytokine levels and inducing this total cytokine and inflammatory load, the eicosanoids are actually involved in a lot of physiological processes. So one of the key factors in the pathogenesis of atherosclerosis, which is inflammation of the vessels, the blood vessels, and normally a precursor to cardiovascular disease, what happens is these eicosanoids actually interact with our cell membranes in our blood vessels, as well as all cell membranes, and they signal adhesion molecules. So they are immune factors that kind of stick immune cells together and say to other immune cells, you need to come this way. So they're signals, they're gatekeepers almost, and they're sort of the helping hand, as if someone's pulling you out of the boat and back onto dry land. That's what these adhesion molecules do on epithelial and endothelial membranes. They stick to an area where the inflammatory and immune cells are needed. They grab hold of those immune cells and they pull them in. Now, EPA and arachidonic acid both produce these adhesion molecules and these chemical signals that say to the immune cells that need to get involved in the inflammatory process, you need to come this way. However, the arachidonic acid derivatives are much more sticky, as it were, than the EPA derivatives. So when we have EPA, you know, the EPA might put its hand out, but it might go, do you know what, actually, we probably don't want you back on dry land, so you can stay in the water. So the leukocytes and the adhesion molecules just keep floating around in the system, in the lymphatics and in the blood, whereas the arachidonic acid, even if you're sat in the boat going, I'm quite happy here, I don't really want to get out, it's going to come and forcefully fireman lift you out and throw you onto dry land because it's so sticky, it just grabs hold of you and drags you in. So that's one of the roles of EPA in actually reducing the progression of autoimmune disease, because a lot of the things that we see in autoimmunity are associated with these adhesion molecules kind of latching on to the protein structures and the endothelial and epithelial membranes of the organs and the blood vessels and the cells of those particular targeted areas and dragging in yet more and more and more immune cells to go on. So the ability of EPA to actually be considerably less aggressive in its stickiness already prevents the progression of autoimmune pathogenesis, which is very, very exciting. Omega-3s in general, we're getting down to some of the more sort of mechanistic stuff here that's still relatively new and not so understood. So a lot of it's kind of based on in vitro and animal models, but we have actually seen in quite a lot of studies that omega-3s can directly suppress genetic replication and therefore expression of cytokines. They can also reduce the phagocytic activity of immune cells, so they can directly reduce the ability of immune cells to kind of munch up and destroy cells. And this is fantastic when it comes to autoimmunity, because obviously we're munching up and destroying cells that we shouldn't be. In addition to that, omega-3s have also been shown to reduce the capacity of those cells that initially take up those pathogens and those antigens represented and presented as triggers, and presenting them on to the B and T cells to then go and proliferate, turn into our Th17 cells and create antibodies. So the omega-3s are really, really quite integral, not just from an inflammatory perspective, but also from the further worsening and onset of the autoimmune process. EPA has been shown to directly reduce the ability of arachidonic acid to stimulate white blood cells, which again, we know this is really important in preventing unwanted antibody production, because it's our white blood cells specifically that produce those antibodies. Another really interesting and exciting, from my perspective as a biomedical and pharmacology specialist originally, is the role of EPA in PPAR gamma. Now, PPAR gamma is actually a transcription factor, which is a very specific genetic sequence that we express at the beginning of a set of the beginning of a gene, so at the beginning of a sequence of nucleotide-based pairs that basically, according to dietary factors and various things in the systemic circulation, will switch on or switch off those those transcription factors and allow the gene to express. When a gene expresses, we then end up with a protein. And in the case of PPAR, PPAR is involved not only in our metabolism of things like lipids and carbohydrate, but it's also involved in the ability to express these Treg cells, so thus involved in immune regulation. So laboratory studies have actually shown that by actively creating synthetic agonists, which are activators of any given receptor or transcription factor, these synthetic activators of PPAR were able to inhibit the immune response in a rat model of autoimmune disease. And the exciting thing is that EPA has been found to directly activate PPAR gamma in cells and in vitro models, which is very exciting, because this subsequently has been then shown activating PPAR will activate the transcription of Treg cells. So if we've got huge numbers of Th17 cells, low numbers of Tregs, by increasing our EPA levels, we can actually increase the creation of Treg immune cells and subsequently switch off, resolve and regulate inflammation and the immune response. So all that translated, because I appreciate there's a lot going on in there, so I'm just going to clarify. EPA can directly reduce inflammatory cytokine load by reducing the arachidonic output of pro-inflammatory cytokines, and this will help to prevent risk of triggering a full-blown immune response. EPA can also help us to stop white blood immune cells from producing self-targeted antibodies, so we can actually stop those antigens from being recognized in the first place, which means the antibodies won't be produced, and then those antibodies can't target self cells. And also EPA has the ability to directly compete with arachidonic acid to produce lesser inflammatory and less sticky immune factors that would normally otherwise contribute the initiation, progression, and severity of organ-specific autoimmunity. Now, as I mentioned, the omega-3s in general all seem to be very important, and EPA and DHA both have a role within the inflammatory process, but EPA specifically has been found to be the most potent suppressor in the omega-3 family of the TNF-alpha and IL-6 cytokines, which are the specific cytokines that switch on and drive the differentiation and production of Th17. In addition, EPA can actually switch off and reduce the ability of our immune cells to destroy self-antigen presenting cells and prevent the destruction of organs and breakdown of cellular functions and structure. As we now know, EPA has the direct ability to reduce the expression of cytokines as well as upregulate the genetic expression of cells involved in regulating the inflammatory process. So it's really, really quite important and integral to be looking at our EPA levels when we're trying to resolve an inflammatory and particularly immune-based disorder. Oh, it's been a long day. I'm nearly there. Right, stress and inflammation. As I mentioned earlier, stress, vitally important in all disease. You could probably say that stress is one of the biggest killers today, because pretty much every disease known to man, well, at least the ones that we worry about here in England, have a huge stress relating factor. So when we're stressed, we are considerably more likely to develop cardiovascular disease, depression, anxiety, autoimmunity, you name it. Stress is more often than not one of the key factors. And certainly I know every single patient that's been referred to me in clinic, when I talk to them through their history, something is stressing them out. Whether it's family-related problems, whether it's personal problems, relationships, work, every single person I know is stressed. So the reason this is so problematic is that stress itself, as we sort of already touched on, actually has the direct ability to trigger inflammation. And of course, the more chronically stressed we are, the more inflamed we're going to become, the more likely our immune system is to go wrong, and then we are susceptible to developing autoimmune disease. The trouble with inflammation is that inflammation, even in the absence of stress, increases our stress perception. And it does this via directly attacking our neurotransmitters, so our serotonin and our dopamine and our GABA and all of the things that help us to feel calm and well. Melatonin helps us to sleep. High inflammation will directly reduce the levels of those serotonin, dopamine and neurotransmitters available to actually help us cope with and deal with stress, which makes us much more susceptible to a stress-related disorder, psychological distress, and psychiatric disease as well. So sort of goes without saying, if we can reduce inflammation, we can reduce our stress perception and our susceptibility to stress as a trigger. And by reducing chronic stress, we can directly reduce inflammation. Together, that's going to directly impact our subsequent disease risk. And just to sort of prove I'm not lying, for those of you that aren't aware of this already, serum polyunsaturated fatty acid levels, specifically EPA, are very, very, very well established now to be involved in both predicting inflammatory load as well as our ability to recognize and deal with stress. Inflammatory cytokine levels and the AA to EPA ratio have been found to correlate directly with all sorts of mental health disorders, but in particular the most well established is depression, and the higher your inflammatory cytokine levels and the higher your arachidonic acid to EPA ratio, the higher the severity or the worse, sorry, the severity of depression. And the studies that just confirm this are along the bottom there. And scientists have now sort of confirmed very clearly that pure EPA at a gram a day will significantly improve severity of clinical depression, and this goes hand in hand with significantly reducing cytokine load. So it's very, very sort of very well established that cytokines, stress go hand in hand. So this is sort of the end of the presentation. What I want to do is I've talked a lot at you about mechanisms and biology and immunology and inflammology and all of these wonderful, exciting things that certainly get my heart racing. But what I want to do is just kind of show you that EPA, as we touched on already, goes beyond just inflammation. And there's a number of studies, and again, you'll all get these slides emailed out, so I urge you to sort of have a look at the ones that we've just touched upon briefly in a bit more depth. I just want to show you that EPA is being studied as a standalone agent in autoimmune diseases, and that a lot of the benefits of EPA are associated with not just the inflammation, but also the genetic interaction with numerous other factors that drive and control the type of autoimmune disease. So this one here is just looking at immunoglobulin A nephropathy, and what we can see here is that this was actually a human study. So although it's relatively small numbers, they were given just under 2 grams of EPA for a year, and they basically concluded that EPA had the ability to improve the creatine output, so improve kind of processing of the kidneys and reduce the clinical impact of the nephropathy that is seen as a standalone autoimmune condition, but it also tends to be kind of a clinical comorbidity in other immune conditions. So EPA was actually able, whilst in this study not statistically significant, probably due to the fact that there was only 23 studies in the whole 23 subjects in the study, but it actually showed that the clearance of creatine and the serum creatine, as well as urinary protein creatine and clinical parameters for IgA nephropathy, were improved with EPA. This one, looking at a rat model of arthritis, actually showed that giving EPA or coconut oil to rats directly resulted in improvements in their myoprotein degradation. So EPA was actually able to prevent the loss of the gastrocnemius or the calf muscle weight. It was also able to down-regulate the transcription of proteins like ligase and that are directly involved in the degradation of muscle proteins. And it was also able to upregulate genetic factors involved in creating new myoprotein structures. So really, really important in preventing side effects of arthritis. So while this study doesn't look directly at the inflammatory load within the joint, it's looking at muscle wasting around the joint associated with arthritis. So it was actually, EPA was actually able to directly prevent atrophy of the muscles associated with an experimental induced arthritis. This one here is looking directly at lupus. It was a pilot study done in humans with lupus, and again they found that fatty acid profiles were changed to favour anti-inflammatory mechanisms in people with lupus when they consumed a high EPA diet. And yes, as I mentioned, please feel free to look at these in more depth. They found that the level specifically of EPA was higher in, the amount of EPA being metabolized and used up was higher in lupus patients. So Rosie, I will have to check that out for you. You'll have to email me about that one. So this one then is a rat model of multiple sclerosis known as EAE, and whilst they didn't see any significant changes in the actual T cell subtypes that were being created, they did see a general kind of resolution and prevention of the degrading effects associated. So they again saw upregulation of proteins associated with protection of the myelin sheath and looking after and rebuilding myelin proteins. And basically, again, whilst there was no significant changes with the EPA, they did find that using EPA in the diet was able to show very positive benefits for multiple sclerosis patients. Another IgA study there, and again they've shown that through modulating expression of proteins, they were able to decrease the rate of protein metabolism and proteinuria seen. Very exciting again, so seeing benefits just beyond inflammatory resolution alone with EPA. And that's just 5 of the studies. There's many, 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 many more. You need to be quite clever at the search terms you enter into whichever database you're searching, because it doesn't seem to like just looking for autoimmune disease. You have to look very specifically. But EPA will pop up all over the place, but obviously with all things kind of fatty acid related, this is still quite new and novel to be looking at EPA and other fats as an individual rather than omega-3 as a whole. So it's quite novel, it's very exciting, it's at the forefront of kind of clinical innovation. And what you'll often find is that because of EPA's direct ability to interact with arachidonic acid in the inflammatory process, EPA as a standalone is vitally, vitally useful and important for a good year or so in any clinical inflammatory management before thinking about other omega-3 aspects to put in. So in conclusion, thank you, Sarah. Have a nice evening. Yes, we will send the CPD certificates out. In conclusion, EPA is able to directly reduce inflammation as well as inflammatory stimuli, which lead to autoimmunity. It can also, through genetics and through the types of proteins it is involved in expressing, directly alter the course of the immune response, therefore allowing us to much more easily control and resolve inflammation as well as prevent the progression of organ-specific autoimmune disease. It's also involved very significantly in a number of mechanisms post inflammation and post immune activation to actually protect and prevent against the targeted organ and cell specific degradation that autoimmune causes, the devastation to whatever organ it is. EPA is involved via transcriptional upregulation of genes, in actually helping to prevent the loss of structural proteins that the immune system would otherwise be breaking down. Something I haven't touched upon, which I will do just very quickly, which you'll hopefully find in a lot of the studies that you'll see, most of them suggest that 1.5 grams to 3 grams of EPA is really optimal. There's a few quotes throughout the papers that I referenced at the end that actually show that anything less than, I think it was 1.35 grams of EPA didn't result in autoimmune benefits. So it's a good place to start, but certainly with our blood spot test, if that's something you feel is useful to your patients, clients, then you will get a personalized dosing guideline for them to actually be able to really understand what dosing you need. So
just for those of you who aren't aware, we are an EPA specialist company. And they're our main anti-inflammatory products that we offer. We offer this very, very tailored, very niche and specific restore and maintain anti-inflammatory protocol. We optimize the body's EPA levels relative to arachidonic acid by offering pure, high-quality, pharmaceutical-grade, prescription strength EPA only in form of Pharmi for Step 1. I'm very pleased to say that's in triglyceride form, so super bioavailable and easy for the body to utilize, recognize, absorb, and uptake. This will restore AA to EPA ratio, will reduce pro-inflammatory production, increase anti-inflammatory product production, get in there right at the genetic level and sort everything out, as well as directly interact with our HPA axis for improved stress perception, so preventing those triggers in the first place. So it's suitable for autoimmunity, mood and psychological disorders, cardiovascular health, any chronic inflammatory related disorder, and much, much more. The Pharmi Step 2 is what we would recommend further down the line once lifestyle, stress, and clinical management has sort of been addressed via various other nutritional factors, and that just introduces the omega-6 GLA there, which is shown to work very nicely in combination with the EPA, and that just looks after the omega-6 pathway to make sure you're producing enough but not too much of the pro-inflammatory, so that you can produce an inflammatory response but you're going over-inflammatory because you've still got the EPA in excess there. So Pharmi for Step 1 will deliver a gram of pure EPA a day per 2 capsules. Pharmi for Step 2, it's just under 700 milligrams, so it's still a really good dose there. And just very, very quickly, this is our vegetarian vegan alternative. So whilst for any inflammatory based condition, we would always recommend that people go down the fish oil EPA route, this is an option. If somebody is looking more for prevention or they're very strict vegan or vegetarian, then the Eki Omega is an alternative. And this is basically the only plant oil available that provides stearidonic acid, which is structurally much more similar to EPA than ALA found in flaxseed. So it's actually able to convert at about 60% greater efficiency to EPA than using flaxseed alone. It's naturally an omega-369 as well, so you still get the benefits of the omega-9 for anti-inflammatory. You get GLA omega-6 in there as well, and it's single ingredient, so there's no blending, there's no risk of oils reacting, and lots of processing have to be done to mix things up there. Plenty more information on our website, and if you would all please take the time to just spend 1 minute filling in our feedback survey at the end of this presentation, you will get the opportunity to try either a Pharmi for Step 2 or an Eki Omega sample for yourselves. And you can also select whether or not you'd like further information, whether or not you'd like some one of us from the nutrition team, perhaps myself, to give you a ring and chat through things in a bit more detail. So these are the references to the science and the immunology bit. The reason why I didn't reference things individually as I went through was because, as I said, I sort of spent days agonizing over the science, trying to pull it all apart and piece it back together. So the first section of slides was really based on all of the papers at once. So there was no kind of one paper relative to each sentence. It was a progression of the science through the last 5 years or so, and then me kind of hopefully correctly interpreting the right messages. So that's where you need to start if you want to do some more reading onto all of this. And then, ooh, that didn't work for some reason. It's frozen. The next slide, which the software doesn't seem to want to let me show you. No, you'll get access to that. Is the studies that I talked about relating specifically to depression, and then relating to the individual mechanistic EPA studies that you saw at the end there. I'm not sure why that's not letting me show you it, but you will get that in the email. Okay, question time. Let me just scroll back up through my chat box if I can. Emma, if you go onto our website, you will find information about a product called Vajipa, which was our original product, and we target that one specifically at children because it's a lower dose of the EPA and GLA. So whilst Farmipa is still absolutely fine for children, especially slightly older children, we would recommend the Vajipa initially for younger children because of the dosing. But again, that's something if you want more information about, if you could just tick that, I can send you some more information afterwards, or maybe we could have a chat. Feel free to email me. Anyone feel free to email me if you need to. You can either get me at education@igenus or sophiet@igenus.com. So any questions that you didn't think of now, or you want some of the specific research papers, or you need more information that the feedback survey doesn't allow you to ask for, then please do email me. Cora, I'm just reading through. EPA reduces inflammation and lowers autoimmune response, but once the immune system has been sensitized and learned to attack, can this be reversed? Okay, so that's where that two-pronged attack kind of comes in. So we don't actively recommend that people need to take EPA for the rest of their lives. Obviously, with our chronically altered diets, people do need omega-3s for the rest of their lives. But if you're addressing diet as a whole, so you're looking at increasing oily fish consumption, you're looking at reducing pro-inflammatory foods, you're looking at high phytonutrient, high antioxidant, high organic veggies, pasture-reared meats and protein sources, reducing stress, controlling pathogens, infections, parasites, all of these things. If you can get your client to a place where their inflammatory load, together with the help of EPA, is low, and you can keep that immune response away from being triggered, then EPA in high concentration for the rest of the life isn't going to be necessary. The blood spot's going to massively help us all in being able to understand the therapeutic application of EPA long term. That said, fish oil obviously is fantastic. DHA plays an important role in the immune response, but via different mechanisms to EPA. So the studies show consistently that EPA seems to work best on its own in isolation in high concentration for resolving inflammation. Once we're confident that inflammation is under control, we're not going lower dose EPA, we're not putting DHA back in and seeing recurrence of symptoms, then we can think about moving people onto a lower dose EPA and ultimately an EPA and DHA containing oil as nature intended. So we are very much therapeutically focused towards making sure EPA does what it should do in the body, but we would by no means say that people need to be on EPA only for the rest of their lives. That said, some people do need it long term because for one reason or another, stress or inflammatory load due to diet just never gets regulated, or there's the constant immune stimulation, and it just becomes very difficult for lots of people to manage. That said, one of the lovely things about the iGenus product, our products, they are very small capsules, so it's very easy to manipulate dose according to your needs. So for example, if you've been taking Farmipa Step 1 for 6 months, which is what we recommend as a bare minimum for inflammatory based conditions, you move on to Step 2, everything's hunky-dory, but then, oh no, wait, really stressful time for 3 months, you can actually just add in another 1 or 2 capsules of the Farmeeper Step 2 to bump up that EPA level again. And a lot of the time people will find that even just the extra 400 or so milligrams of EPA you would get from adding 1 capsule back in for a period of 3 to 6 months suddenly calms everything down again. Stress is resolved, naturally reducing inflammation in its own right. Then you know, can look at other factors as well that help to control that. And then you can go back to just taking 2 a day of Farmeeper Step 2, maybe over the summer when your skin is better and you're not so stressed and all of these things. So they're very, very, very adaptable. Similarly with Farmeeper Step 1, somebody who's got a really severe clinically chronic inflammatory condition like autoimmunity, we would generally recommend start them on 4 capsules a day to give them 2 grams. Then after 3 months, if you're already seeing great results, go down to 3. At 6 months, 2. Stick with that and then move on to the Farmeeper Step 2. And you can swap between products as much as you need to. Just because you've gone on to Step 2 doesn't mean you can't go back to Step 1. Similarly with the Echiomega, it's perfectly safe to take up to 10 capsules a day of Echiomega. So again, if someone's chronically inflamed and they just won't take the EPA, we would recommend minimum of sort of 8 capsules a day of Echiomega, and then slowly reducing down as diet and lifestyle factors and trigger factors are addressed, leaky gut is healed, parasites are eliminated, and so forth. I hope that helps. There's a lot of information there. But if there are no other questions, I shall leave you all in peace to enjoy what's hopefully left of a lovely evening. It's been thoroughly splendid here in Cambridge. I hope it has been where you all are. You now have my email address. Please fill in the feedback survey to get your free sample and any follow-up support that you need. And I very much look forward to hopefully speaking to you all soon. Have a lovely evening, everyone. Good night.